Alfred Nobel was born in Stockholm on October the 21st, 1833. At the time, the family was in serious financial difficulties, and that same year, Alfred's father was forced to declare himself bankrupt. He'd made a name for himself designing naval mines. After becoming insolvent, he went to Finland and then Russia to start a new career. The family finally joined him in St. Petersburg in 1842. Alfred was taught by a private tutor. He showed an interest in the natural sciences, but literature too held a particular appeal for him. To turn the young man's mind to other things, in 1850 his father sent Alfred on a study trip to England, America and France. In Paris, Alfred worked as assistant to the chemist Théophile Jules Pelouse. A few years previously, he'd also taught Asciano Sobrero. In 1847, Sobrero had invented nitroglycerin by mixing glycerol with saltpeter and sulfuric acid. But Sobrero never managed to explode the new substance under controlled conditions. When an accidental explosion left him permanently disfigured, Sobrero abandoned his attempts to find a technical application for nitroglycerin. When Alfred Nobel returned to St. Petersburg in 1853, he immediately embarked on research into the new substance discovered by Sobrero. It fascinated him. Not only did nitroglycerin have 6 or 7 times the explosive effect of black gunpowder, glycerol was also a very cheap raw material, a byproduct from making soap. But at first, Nobel too could not control the new substance. So in 1863, the Nobel's firm went bankrupt once more, and the family returned to Stockholm. Alfred now began to make an intensive study of nitroglycerin in order to finally turn it into a manageable explosive. One of the main obstacles to the industrial production of nitroglycerin was its sensitivity to heat and vibrations. Even the slightest jolt caused the oily liquid to explode, ruling out any civil or military application. But Nobel had an idea. With the help of a detonator, perhaps, nitroglycerin could be made to explode safely under controlled conditions. On July the 15th, 1864, he applied for a patent for his initial igniter, as he called it. It was perhaps his most important invention. Through the ignition of a small amount of mercury fulminate in a blasting cap, a large quantity of explosive could at last be detonated under controlled conditions. Nobel, it seemed, had tamed nitroglycerin. Now production could get underway in earnest. The company began to make a profit. But then, the Nobel's laboratory in Stockholm exploded, killing 5 people, among them Alfred's younger brother, Emil. The city of Stockholm's immediate reaction was to ban all experiments within the municipal area. Despite this setback, Nobel continued his research. The explosive simply had to be made safe for industrial application. Nobel tried to bind nitroglycerin with different substances, such as gypsum and wood shavings, in order to make it insensitive to jolts and vibrations. But at first, he couldn't find any solution to the problem. But Nobel was convinced that the accidents were only the result of the material being wrongly handled. Chance came to his aid. In Krümmel, some blasting oil escaped but was soaked up by silica, a porous, absorbent, sandy material which the transport crate had been filled with to protect the explosive from jolts. Formed from the skeletons of primeval algae, silica was the substance Nobel had sought for so long. It made the volatile blasting oil insensitive to jarring. What's more, silica was very cheap, since there were large deposits of it near Krümmel, which could be mined with ease. Nobel mixed 3 parts of blasting oil with 1 part of silica to create a paste. He thus obtained a new solid explosive that could be formed in whatever sized portions were required. Because of its enormous explosive force, he called it dynamite, from dynamis, the Greek word for power. This was the explosive the world had been waiting for. One big advantage of Nobel's dynamite was that it could be manufactured in stick form. New drilling techniques meant that the explosive could now be detonated inside the rock itself. And because of the enormous explosive force involved, it was possible to literally move mountains. At long last, major projects like the Gotthard Tunnel, the Corinth Canal and the Panama Canal could be embarked on. The 81-kilometre-long canal through the Isthmus of Panama finally linked the Atlantic and Pacific Oceans, more than halving the sea route from New York to San Francisco.